Crazy.
Yeah, crazy. All right. Oh, okay. Yeah. So we gotta start with that design doc, right? Um.
Kind of already did. I still have the temp.md open right now.
Yeah. Yeah. But let me rewrite it so it actually sounds like half decent.
Yeah, because you were like half asleep when you wrote it.
Yes. But yeah. Well, no, I wasn't asleep, but like I was just kind of like slapping it together as fast as possible. So
Essentially.
yeah.
Yeah.
Okay. Um. I'm just gonna edit it on the GitHub. Oh, actually, I guess I can do it.
Yeah.
Uh.
Yes.
Excuse me. Yeah, I can do it on the GitHub, or I can just. Oh, 10 stars! We're at 10 stars! Say who?
Wait, really?
We're at 10
Really?
stars!
Seriously?
Let's
Let's
go!
go!
Let's go!
Let's go!
Yay. Let's see.
Let's go, finally. 10
Nice.
stars.
Nice, man. Nice. Sweet. Okay. All right. Yeah, let me,
Double digits.
huh?
We're at double digits.
I know. I know. Let me, go and here. Where's the, okay. Where can I find the goddamn milestone? 'Cause this is actually gonna make you crash
Yeah, I
out.
don't know where you're supposed to be able to find it.
Yeah. Is it just like
Like
magically
I believe you
non-existent?
like attach it to I believe you attach them to issues, to individual issues.
I mean, that sounds right, but I still can't find it. But no, it just. Wait, milestones. There we go. Wait, here. No. Can I just link? Oh, why is the milestone just like non-existent? Um,
Oh, you go to issues and then you go to milestones.
wait, is there like a sub?
See, or
Oh,
what you go to pull request and
I
there's a
see it.
button that
Yeah.
says milestones. Yeah.
Thank you. Okay. Uh, yeah. So let me see. Okay, let me get attempt.md.
And I don't
Um,
really like the name of this thing. I'm gonna rename it to this like engine implementation because I think that might be a little
that's
bit
fine.
better.
Yeah, that's fine.
Tongue implement. Yeah, okay.
No, no, yeah, that's fine. That's valid. Um,
Engine.
okay, let me. We're gonna write this like a professional design doc. Okay. Things to confirm. Not. I word this properly. Okay, I guess things to. Uh, Completing this milestone will require both uh, with a checkup on old code, and uh,
You should also link the BEPs for each one of these things.
right. Okay. Um.
Because I noticed in our qubits README they like link each BEP that they implement.
Yeah. No, you're
I'll
right.
steal a lot of code from them.
Yeah, we do. Uh, so
Could. We don't do. We haven't stolen any code from them.
we would never do that.
We haven't yet. What do you mean?
Exactly.
Yeah. No,
Exactly.
we have not stolen any code from that repo yet.
Exactly. That's the
And what I
mindset
mean by
I'd like to see.
and what I mean by steal is we're not actually stealing. We're just gonna like use it as a reference. You can't really steal their code because their infrastructure is completely different than the way we're doing
Yeah.
this. So
Yeah. Yeah. Tell everyone that. Tell the entire
don't
chat
look,
that.
man. They only support TCP peers, by the way. Like we support
Oh.
UTP
I know. I know.
also.
Okay. Anyways.
You know, he's the person who made the UTP library we're using, but we don't talk about it.
uh, this tracker should have been refactored and implemented properly in 77. However, it would be appropriate. Wait, that is like 77, right? Hold on.
Pretty sure it's 77.
No, I'm very sure it is. Yeah, no, it is. I just want to check it. However, it would be appropriate to blah blah blah. However, it would be appropriate to ensure that this feature of the engine is working, and possibly I'm gonna sneeze. Oh my god. Uh, oh yeah. Okay, we're alive. We're alive. It's fine. It's fine. Um,
So 77 is the issue that addresses all of it. It's not the actual PR that fixes it.
that's fine. I mean, well, mm, no, yeah, maybe you're right. I say that, but maybe you're right. Here it's 84
Yeah.
and 84. However, we prefer to ensure that this feature of the engine is working properly and possibly abstract it into a separate function for the sake of testability. Okay, for the infodict. Trackers rely on trackers at the moment rely rely on BEP3 and BEP15. So BEP3 that's BEP3 and BEP15 are the two BEPs for tracker
Yes,
stuff, right?
I
Okay.
believe so. Yes.
Yes, that sounds right, but should double check. Okay, and BEP15. I can look real quick, but I'm very sure it is. Yeah. I mean, either way, I can just say that's what it currently relies on. Relying on BEP3 and BEP15. Infodict.
I think a better way to put this is to just have like a BEP section at the end of each one. So just have like
Okay, yeah, that's fair.
BEPs.
Yeah, just put in a list. Okay.
Oops.
Yeah, there we go. Yeah, you got the yeah. Okay. While this feature should already be implemented in the handle peer function, we should ensure that it is well, the feature should already be implemented in the handle peer function. We should ensure that it is working as intended with multiple different peers. This includes, I can move this up. So here, do this, and then go back here. This includes ensuring that the infodict is being sent back to engine. No pieces are requested until full infodict is acquired. Okay, and then what else? No piece until full infodict is acquired. And what else? Okay, so ensure that the infodict is sent back to engine. Ensure that the infodict verify that the infodict is collected and hash verified correctly. Is that a word or a phrase like hash?
Is what a word?
Hash verified, line 20 in temp.md. Okay, is that just verified by hash?
Yeah, verified by hash.
Okay.
Verify the infodict is collected. Verify the infodict is corrected. And there's a better way to word this because you're using the word verify twice.
Oh yeah,
verify
yeah.
verify that the infodict is collected and correct by comparing by hashing incoming infodict with our predefined hash from the magnet URI.
There we go. Yeah, that should be fine.
Magnet URI. Oh, oops, I mean, is that close the file on accident?
Verify pieces before we have infodict. Thus ensuring bus. This feature working correctly. This feature working correctly is extremely important. If we do not have the hashes of each piece, peers could potentially send malformed or malicious pieces without our knowledge. Okay, and then what BEP does this rely on? Like
extended messages and
oh
like
right,
the metadata,
yeah,
something like that.
Yeah, no, you're right. Thank you.
Yeah.
Just because there. BEPs.
Peer disconnect. Up 11. I think handles peer disconnects. Peer exchange. Oh, that's PEX.
Yeah, I was gonna say.
Protocol extension. So BEP 11 is peer extension, I think.
Yeah.
Let's see. Disconnects.
What
Peer
is
must only. I feel.
allows peers send here allows peers to send metadata files. Okay, and then BEP 10. We'll kind of just paste this in here and then just defines another. My girlfriend is calling me. Hold on. Another peer message type. Honey, I'm working on Rust. Hold on. Alright.
You know what?
Hold on, chat. Sorry, chat. I missed oh, general. Wait. Okay. There. My cat is still like fast asleep because that's what my cat does.
Bro.
Look at him. He's all flopped over.
Usual.
Yeah.
What?
Huh? What now?
Where'd my stuff go? Oh, there. I can do here. It goes. That was weird.
Okay. Defines another peer message type. Okay. Check handshake. Handshake. Okay. Thus, I'm unaware of the. Thus, we are. We're gonna say we. We're gonna assume that it's everyone's fault. It's equally everyone's fault. We would like to try a few various peers. Make sure that this is correct.
Hold on 1 second. I'll be right back. Give me like 10 minutes.
Okay. Oh wait, 10 minutes. Oh my God, where's he going? We should run a test with multiple different. We should run a multitude. That is not how you spell that. A multitude. There. That seems right. Is that right? I don't know. Hopefully it is. Okay. We should run a multitude test to do that. Blah 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 blah. Okay, and then. Oh, we already added the BEPs for some of these. Okay, sweet. The handshake is BEP 01, but it's still. I mean, it's still kind of bad. BEP 01. Defines the general bit torrent protocol. Okay, things to do. The fun part. Okay, receive and handle a piece. At the moment, the engine does not handle bit fields appropriately. Handle received bit fields appropriately. My Oscar's proposed solution is to utilize, actually let's just say we, there's no reason to say my. Our proposed solution is to use the hash map to maintain the rarest piece for a given torrent. That hash will be appears as a bit field in the general process will look something like this. It appears in bit field, we send a bit XOR, put that back to the engine. How do I say this? I encourage, if you, let me see, because this doesn't always work, or well, there's a situation in which this would not work, but the chance of it not working is very slim. So, this, the XOR, the bit XOR function will act as expected because there is no rational scenario where a peer will lose a piece, aka remove a piece of from its bit field. The only thing I want to do is go up here and change this to using a little bit. We've no, okay, no, you want. I was gonna say I didn't think you would. Using a little bit as inputs back to the engine. Short bit and assign. He'll appear. This function is running until either the torrent function ends, the period disconnects. Repeat for new bit fields. Dash map. For a piece that the peer has, or a piece that is in the bit field, we will increment that part of the hash map. Alright, that part of the hash map. However, we might also be able to simply use a vector for this. As the rarest piece, I think this could be costly, seeing that there may be a loose upper bound of 10. Okay, I feel like this is very poorly worded. Getting this could be costly, seeing that there may be a loose upper bound of 10,000 pieces. In other words, we generally expect most torrents to have a maximum of about 10,000 pieces. To 10,000 pieces. If that is the case, getting the minimum value of a hash map or vector that is 10,000 bytes long could be extremely costly. Especially if we have to, blah blah blah. Words are hard for me sometimes, guys. Words are very hard for me. Especially if we have to constantly recalculate this value. Cache is piece. Yeah, blah blah blah. Every X bit fields receive, recalculate piece. Pros and cons, and we will make the choice of what to implement sometime. Oh, that's okay. And we will make the choice of what to implement somewhere in the near future. Okay. handle piece and request flow. Request piece, write piece first. The primary challenge here is actually storing the piece on disk, specifically non-memory. That will be a major problem for a number of reasons. Storing piece in memory is outlined. Wait, in memory? Wait, storing piece in on disk is outlined in the next section. The means of storing piece on disk, storing a given piece on disk is outlined in the next section. A bitvec should be maintained that tells us which pieces we already have for the sake of seeding. Seeding is outlined in a few sections down. This doesn't have to be perfect, to be fair, but it should just be like decent, you know. I also need to attach BEPs. I've been forgetting to do that. Okay, the question I have is, there's not really a BEP for this. I guess where the bit field is, hold on, let me see. BitTorrent, rarest piece, BEP. Let's see if I can find like a BEP. Let's see if this post links. Absolutely not. Okay, wonderful. Okay, actually, well, there's something interesting here, because fast extension, okay, this might be interesting. Allowed fast. Okay, let me also include this, because we might also want to receive, or get stuff based off of that, which would be doable. So here,
I'm back. Hello.
hello. Okay, this,
What I miss?
not really anything, just more documentation writing, or outlining, I guess.
Yeah.
This should be extensible enough that selecting a piece based on the allowed fast attribute. That should be wrong button. There we go. Fast attribute. This should be based on the allowed fast attribute of an extended message could be implemented in the future. See BEP 06. Is that even an extended message? I think it is, right? I think fast extension maybe, I don't know. Of a extension.
So do you want to build the engine with torrenting multiple files in mind?
Ooh, that's a good. Yes, but it shouldn't be too hard.
Yeah, that shouldn't. Well, I feel like it would be easier to build it with that mindset in mind from the
Yeah.
start, from the ground up, than it would be to implement it later on.
No, I tend to agree with you there.
Well,
That seems fair.
so while you're doing that, I'm going to start writing up the syntax for like the functions that we want to have inside the base engine
Okay.
that
Okay.
should be public.
Yeah.
I'm going to start writing up the syntax, which we should in which the engine should look like.
Okay. Cool. Sounds good. Yeah. Definitions of gaps. I don't think we really. I guess there's not really. Okay, there's not really. Yeah. Unless there's something here. See, no. Okay, there's not really anything. I guess I'll just add BEP1. That'll kind of be the only thing that we really need to link there. Okay. BEP1, piece and request flow. Okay. BEPs. 6. And link to here, copy BEP6. Okay, what else is mentioned here? I guess this is kind of just gonna be like, actually, I don't know what this is gonna be. We handle piece and request flow. Maybe. Well, no, it should be. Just should be about 1, I guess. Defines the general bit protocol. Defines message types. Beautiful. There we go.
I would like to. I'm looking at the WebTorrent documentation for reference
God.
on
Okay.
how like there's no like I'm looking at it for reference on how they like make their torrent engine basically.
Mm.
So they actually WebTorrent actually defaults to a sequential strategy where they just download each piece in the order that they're given.
Mm-hmm.
So they have two strategies. They have a strategy where they have the rarest and the sequential. Do you want to do something like that?
I mean, we could, but
Where
like.
the user can decide which strategy they want to use?
Okay, normally I would say yes, but I want to see that in action. Okay, I want to see another more reputable torrenting client that has that implemented because it's WebTorrent and I don't exactly trust them for a quality standard. So,
Fair enough.
yes, if you see that anywhere else, yes, absolutely, but um,
Mm.
I just don't trust them at all.
Or
Okay, creating appending and closing a file. Currently, journal flow logic is this. I guess there's certainly BEPs mentioned here. Haley period disconnects. BEPs none. Okay, so how do we want to handle torrents with multiple? Actually, hold on. Let me just look at a multi-file torrent. I think okay. So the two main things that we need to worry about are multiple files, obviously, and then folders for those files. So
the path is specified in the info dict.
okay, let me hold on. Let me open torrent. Let's read that code online.
It's
Um,
X. Or,
huh?
oh, well, never mind.
The what now?
Never mind. My fault. Nothing.
Okay.
Never mind.
Okay. I'm gonna go and see. I just want to see what one looks like again because I
Don't
kind
link
of.
any files, Oscar.
Which file? There. I'm not Epstein, dude. Like. No. Okay. Test. Torrents. Big web by chef multiple. Okay. Yeah. Here we go. Okay. So. Yeah. So there's just multiple files. So. Yeah, that's gonna be because I. Okay. Here. Firstly, let me do. Okay. There are two main challenges in handling a torrent with multiple files. Firstly is the multiple entirely separate files themselves. Okay, so how do we download a single file and then
Well, they give us a length property, and the length
mhm,
on paper theoretically should be divided. So we have three numbers. We have the length of each file. We
mhm,
have the amount of total pieces that we have,
mm.
and then we have the length of each piece. Now,
Okay.
I'm sure you're a math man. I'm sure you can figure out like with those three numbers, there's some way you can figure out what piece each file starts at, and
Yeah.
that is a formula I'm going to leave to you to
Oh,
to like
great.
figure out
I
because you're the
don't
math
like.
man.
I'm not. No, 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 no. This has nothing
You
to
have
do with.
three variables.
Has
Do something with
nothing
them.
to
Create a
do.
function.
This has nothing to do with calculus. Okay.
You're the math man. Come on, calculus.
Whoa. I can take the integral of those three variables. You want to do that?
I don't know what that means, but yeah, you got that.
Wonderful. Um, wait. Okay. Yeah, because we can't really. Okay. So okay, I'm gonna assume that the files are given in correct order, right? Like,
Yes, they are. They are.
okay. So then.
So, the order of the files that they appear in the bend code is
Hmm.
the same order that they will be in pieces.
Okay. Do you have a source for that?
Um, I believe I read it at some point, like in the BEPS at like 1 a.m. or something. I don't remember exactly where,
Okay.
but I remember reading it somewhere in the BEPS.
Okay.
I just don't
That's
remember exactly where.
okay.
And I think I also saw it when I was watching John code his torrent client.
John. Oh, yeah, yeah, that guy. Yeah. I was gonna say
Yeah,
like John. John. John can help us.
yeah,
No, that makes sense. Okay. Uh,
yeah, the guy who's bald, who's really good at Rust,
yeah, yeah. Well,
or balding.
that's like multiple people, dude. How that doesn't help me at all.
Basically, the whole Rust community.
Yeah, pretty much. Anyways, um, okay. So the files are given in are provided in correct order. Are provided in correct order in the torrent client. Or are provided in the incorrect order in the torrent file slash magnet URI. Do magnet URIs actually support multiple files?
Well, nothing about them stop. Yes, it does support it because we don't. So basically, it supports it because they don't provide the info to begin with, so we won't know what files the actual torrent
Oh,
has.
nice. Okay,
So we
great.
have to get the info dict before we can even do that.
Mm-hmm. Point taken.
That's why magnet URIs suck.
Yes. Yes, I agree. Okay. These files are probably.
So yeah.
Yeah.
Apparently, WebTorrent supports literally like with apparently via DHT you can like start a torrent with only the info hash, like not even the magnet URI to get announced or anything.
Oh,
Like you
seriously?
just do it with with just an info hash. That's all
That's
you need
yeah.
to start torrenting.
That's nice. Sweet. Yeah, that'd be nice.
So I
Okay.
guess that's something that we should do, I
Yeah.
guess, at some point.
Yeah. Oh yeah. Hold on. I forgot to
Yeah,
put.
we should probably add support for DHT.
Yeah. No. But that's the future. Um. Hold
Fair enough.
on. Let me. I forgot to add my join up Discord message. In my chat. So I gotta do that real quick. Um.
Yes.
Yeah.
Chat, join his Discord.
Join my
Very weird.
Discord. Join up, and then we pin that. I think I edit the. Hold on. I think I edit the. There we go. Because I made a community server, and now the link changed. There, beautiful. Okay. Anyways. Okay. Okay. So the files are provided in sequential order in the torrent file, or mag URI. Well, actually, all right. In the torrent file, if we are torrenting off of a magnet URI, we will not know what files there are until we get the info dict via BEP 09 or 9 slash BEP 010. Okay, and then BEP 09 is here. And then BEP 10 is there. Okay. Okay, okay, so is it, okay, my question is, okay, if I request a
Formatted
P,
this wrong. Continue.
no, huh? What? Huh? Oh, what? Oh, okay, well, yeah, but I see, I had via PEP. Oh, I guess you can't, okay, so I guess you would just do like, okay, point taken. Um, slash PEP, okay, point taken. Um, oh, there we go, okay, so my, okay, if I have, well, here, if with the Big Bug Bunny torrent, um, okay, so the
Mhm.
first file is a file that's only 140 bytes. If
Mhm.
I request a piece and the piece size is, I can't imagine, wait, actually, it doesn't say the piece size, so I'm assuming it's 16 kilobytes. If the piece size is 16 kilobytes,
Really? It doesn't say the piece size? Seriously?
oh,
Should.
wait, piece length? No, no,
Yeah.
no. No, wait, no, but,
Piece length is piece size. Same thing.
oh, okay, but wait, hold on. Piece length is 200,000 something. Is that bits? No. That still won't be right because that's, huh?
Wait, so the piece length is less than the smallest file?
No. The piece length is much greater than the smallest file, but the piece length is greater than 16 kilobytes. And I thought,
Yeah, I've seen files that are. I mean, I've seen torrents.
mm-hmm.
I've seen torrents that have piece lengths up to like 8 MB,
Oh,
like
okay.
commonly.
Okay.
That's not, 16 kilobytes isn't really that standard,
Ah, okay. Um,
but you would assume the piece length would be smaller than the smallest file. Otherwise, how are you supposed to split up those files?
yeah, see, that's my question is, are we, okay, so, okay, the piece length here is like,
Well, since we know for a fact what order it comes from, we can, and we know the length of that file.
mm-hmm,
We could just kind of like, I guess you would have to like split up that chunk.
mm-hmm.
I mean, split up that piece basically.
That's, see, that's kind of what I was thinking is that, yeah, because like we have to break it up, don't we? Like we can't
Yeah.
just, yeah, we can't just request the, um, like that file separately. Like, okay, like the first piece request is not going to cut off, um, at 140 bytes just because that file is,
Well, we
excuse
can
me.
cancel the piece request now and just stop it, right?
Well,
Can't
yeah,
we do that?
but still, I mean, we would have to split it because we would get that entire file and then
Yeah.
have to move on to reading the next part of the file, which would be a bit of a challenge. Doable, but just a bit of a pain.
Yeah.
Okay. Um.
Right.
Yeah. Well, that's probably okay. If we
Look
were
into
to,
our qubits syntax too.
oh God, yeah. Okay, that's probably smart. Hey, Charles. Charles. It's coming back. There it comes. Retorting off of a magnet URI. Nope. That's just, no. There's nothing in there, dude. If we're trying to find URI, we'll not know what files there are until we get the info dict via Beppo 910. Managing separate files is a challenge, obviously. Blah blah blah. Okay, so managing separate files is a challenge due to the fact that uh,
Download magnet.
that
Transport handles.
as far as we are aware, uh, the end of one file in a piece message piece message is is the same is the start of a is the same as the start of another file in a another file. Morse an example is shown below. Okay, how do I do this? So what's the best way for me to illustrate this? I guess we had that way would be great. So, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 0. Okay, then asterisk.
Archix? Sorry.
Huh? What?
Sorry, my fault. Yeah, you're right. You got that. My fault.
Huh?
Like,
What'd you say?
nothing. Just continue. Sorry.
I'm so wild. Okay. I'm so,
Just
okay.
continue. Just continue.
I'm okay.
Continue. Just act like it never happened.
What'd you even say?
Act like it never happened, bro. Like, you're extending this. Just go on with your day. Act like it never happened.
What? How I'm worried. How I'm gonna go back and watch the VOD later and see what you said.
Okay.
Okay, just like byte x may mark the end. Byte plus 1. Byte x minus. Byte x plus 2. Hold on. My alarm's going off. Hey, Travis. Oh, I stepped the connection. Goddamn. No, fine. I know. You're a cute little munchkin. Look at you. Oh, yeah, look at you. Wow. You got food? Yeah. You got food. Okay. Hold on. I turned off the cat cam.
Rip.
My
Rest in peace, Cat Cam.
my 2 viewers aren't gonna be happy. I guess reconnect. I think.
You're lying in your title.
What? I know. I'm lying.
You're lying.
What was that?
You're lying.
That's so weird, man. So weird. Okay, why is it not connecting now? Oh my god. Why is my life so hard? Droid cam. Yeah, you're gonna be fine. Connect. Connection reset. What do you mean? No, it should work fine. Huh? Hold on. Maybe I like turn it back on. Hey, Joss. Okay, here we're gonna like restart. There we go. Okay. Hey, Joss. There we go. Okay. I don't know why it wasn't working. Okay. We're back up. Don't worry, everybody. Okay. A diagram of a piece message around a given byte x byte x bytes through the piece. By x may mark the end of piece the same as by x may mark the end of a file, but byte x plus 1 may mark the start of a new file. Handling this is going to be a pain in the ass. Handling this will be challenging. Will be challenging. Okay, 9, 10,
So, what I want to do here is our implementation. I'll do something like,
oh, there you
I
go.
want to have functions for, new. should just return engine. And then
Challenging.
that's it. Oh, it's info.
Secondly, second
New and then so from info. So create that.
issue lies
Okay.
in handling files. There can be torrents that have like folders, right? Or that have multiple
Yes,
files.
definitely.
Yes. Okay. I just
Yes,
wanted to
that would be
check.
specified in the path in the info dict.
Yeah. Yeah. Okay. Handle files subfolder. Handling multi-file torrents. Multi-file torrents subfolders. This should not be as challenging. This should not be as challenging. Should be manageable as once the above slide in. As once the above issue is solved, as once was managing separate files is solved, we can simply check to see if the given file should be placed in a subfolder, and if so, create a subfolder if it does not exist. Okay, beautiful. That should be reasonably easy. Okay, seeding.
This thing. Alright.
The engine currently has no implementation for seeding. Seeding in itself is simple, however, managing a choking algorithm is important. However, managing a choking algorithm
Here's
a
some
proper
sense.
choking algorithm could be tricky.
If no tolerance for a
However, managing the choking algorithm correctly could be tricky. Managing the choking algorithm
torrent.
correctly could be tricky. Directly. To handle the basics of seeding, request peer messages, request peer messages should be passed onto the engine from the peer thread that the message was received on. That the message was received on. I mean, I like definitions section. Definitions. Peer thread. The thread that a handle peer, that call to handle peer in the engine. Engine is spawned on. engine struct itself, usually in reference to the torrent function. Okay. Oh, throw it down a little bit. Okay, 22 down. That? Huh. What do you mean? Okay. Whatever. Because all these are all these are to do. From the pure thread that message was received on. I'm gonna make a little bullet point again. Basics of seeding. The following should be implemented. I should pass on the was received on. If we have the piece, we should send the piece. We should send the piece back to the peer thread in a peer command. No. The peer should then send the piece back to the peer. Beautiful. Okay. As for managing the choking algorithm, okay, is there any BEP about the choking algorithm? Because
I don't know. Probably Google. I don't remember. I haven't really done any look. I haven't really looked into anything with involving choking and stuff like that. I haven't
yeah.
looked into that. I'm pretty sure you linked a video to it in your BitTorrent deep dive at some point.
Oh yeah. I'm there, bro. I look up choking algorithm BitTorrent. I literally get my own post. That's how few resources there are. Oh my god. Okay. There is a white paper. Maybe this is. No, this is like. Wait. Maybe. Oh wait. No, this is like. Oh, is this the goddamn cryptocurrency for BitTorrent? Oh my god. I think it is.
Yes.
Oh my god. This is so dumb. I'm sorry.
Just document your stuff, please. It said BEP 52, I think.
No, wait, hold on. I will check there. I think that's. I can't imagine it's like what is this the BitTorrent? Oh, this is V2. Let me see if it mentioned anything about choking. Um, wait, maybe. Wait, is choking only BitTorrent V2? Wait, no. Wait,
It
hold on.
shouldn't be. No, definitely not. Definitely not.
Hold on. The choking
Definitely not.
algorithm described below is currently deployed one. It's very important. Okay. Okay. I'm gonna say that it is described in 52. I don't know though. As for managing the choking algorithm, um, BEP 52 should be referenced. Okay, then definitely reference that here. Okay, BEPs.
Yes.
BEP 52 defines BitTorrent v2, but also the choking, the currently implemented choking algorithm. Okay. What other BEPs do we reference here? Is there a specific BEP for seeding, or is that kind of just like BEP 1?
Pretty sure it's BEP 3. I'm not sure though.
Okay.
I don't remember.
No, that's fine. I'll look. See if mentions here. BEP BitTorrent seeding. No, I don't. Actually, no, you're right. It probably is. F3. Yeah. Bep of 3. Uh, gives an overview on seating.
So apparently, you know how most clients have a throttle upload and download rate?
Yeah.
Don't really, how will we even implement that?
Um.
Because that's like a common feature for like every current client. Like almost every
Yeah.
single one has it. What would
Um.
you, how would we do that? Like
I
we have like the statistics on how many bytes in and out that we're getting. Like we can create statistics for that, but how do we limit that?
I do not know. Um.
We could like try like sending bytes slower, I guess. But because like it is an important feature, especially for mobile users.
Yeah.
And this library is intended to be like completely cross-platform, able to be put almost anywhere.
Wait. Mobile?
So yeah, you can run Rust on mobile. Yeah,
Oh, I did not know that. Okay.
yeah,
The more you know.
yeah.
Wait. What if we just if the bytes per second are higher than a certain threshold, how about we just cap it? Or sorry. How about we just don't let any more piece requests be sent or taken in until we pass
Mm.
that.
Yeah, it could, I guess. Like we could just stop all of our requests,
Mm-hmm.
and I guess we might have to cut off some pieces that we're receiving, which would hurt the download rate. But I guess that's kind of their problem because they're the one who set the download rate to be too low. So
Yeah.
I guess that could be something that we do.
Okay, let me add that here. Limiting the download
I
rate.
think honestly that could be a separate issue though later on. I don't think that should be in our initial
Okay.
yeah, I don't think that should be in our initial
Do we need to go
um
ahead?
engine implementation.
Do we go to
That
go
should
ahead?
be a separate issue.
Yeah. Do we go ahead and add that as an issue just so we don't forget about it?
Yeah, definitely.
All right. Um.
It should be after we've already completed the
Yeah.
engine.
Yeah. Limit. Um. Add a feature to limit. Bit torrent. To limit download slash upload rate. This is a common feature amongst most popular BitTorrent clients. Ideally, uh, it should be reasonably simple. Should be reasonably reason. Oh my god, I cannot spell. Reasonably simple to implement. If a torrent, if the bytes per second surpass a certain, if the bytes per second pass, per second either upload or download surpass a certain threshold, then no more pieces should be sent or okay, received respectively. Sent bytes per second, either upload or download, If a certain threshold, then it should be sent or received, respectively. Okay, that seems reasonable. Labels. This should be a enhancement. Low prio, and that should be fine. Let's add it to tortillas, and don't assign anybody. Okay, cool. Wonderful, beautiful. Okay. Let's see. Okay, so that should be okay. Yeah, so we're not gonna do that there. Okay, Okay, this is what I need to think about now: is how we're gonna see when a separate file is. It's gonna be kind of a pain to do. It should be doable, but it's gonna be kind of a pain. Okay, let me think about that a little bit. So, uh, hmm. Okay, so ideally we should. Oh my gosh, my brain is spinning right now. Okay, if we have a here, we're gonna go the whiteboard. If we have a piece, uh, actually here, let's do it like this. This is piece one. This is uh, piece two.
Back.
Okay, I'm trying to figure out how we determine where different files end and start in a multi-file torrent in a piece message.
Hold on. Repeat that.
I'm trying to figure out how to determine where a piece, where a file ends and starts in a multi-file torrent in a piece message. I think it should be reasonably simple. We just need to keep track of the length of each file since we can go sequentially, but I need to actually write that out.
Mm.
Um, handling. Okay. Um, I'm gonna put like more suggestions. Suggestions are welcome. Okay, so okay, let's see.
Okay, I figured. I think I have an idea.
Okay, okay.
Do you have where are you documenting this?
Line 120.
So if we have, so with some, I think we can do this with some basic math. Is we
Yeah.
can calculate the start piece and the end piece, and then we can calculate the remainder. That's what we can. That's what that would be called. The remainder needed from that piece to fill the end of that file.
Okay. The the oh, I realized something. Because we aren't getting pieces sequentially.
Yeah. So that is, yeah.
Yeah. Um,
Wait, what's wrong with that? What's wrong with, wait, what's the problem with that?
Cause how we're gonna have to maintain some.
And also that makes seeding a little bit harder.
Yeah.
Some of the parts of the seed will, I mean, some parts of each chunk will be split up into multiple files.
Okay, we might need
I mean,
like.
each piece might be split up into multiple files. That's a possibility.
Yeah. Okay, we maybe we need like multiple. Hold on, let me think about this. Maybe we need. Okay, no, no. Oh, okay. Maybe we
Well, and remember, pieces are split up into blocks, remember?
yeah,
That could be useful.
yeah. That wait, how big is the block again?
I don't remember. I think it varies from torrent to torrent.
Oh, I guess that does make sense. Okay, so maybe we. I was gonna say like okay, if we had like a separate struct to manage those pieces, and okay,
Yeah.
so
Um, I think I don't think it'll be that bad if we can have the if we can have the piece start and piece end for
mhm,
each file, and
mhm,
then have the remainder, which is like the amount of bytes in that last piece that it needs, and we
mhm.
can keep that somewhere. We can have like a map for each piece and where it should be in each file, basically.
Yeah, that's yeah. Um, okay, so potentially, okay, instead of having a list of pieces that we do or don't have, what we could do is we could have a list of, excuse me, let's just say like custom file structs, and then each custom file struct has the list of pieces that we have for that file, and it maintains the memory location, or well, the disk location of that file and all of the logic with it. How about that?
But I'm confused on why we would need to do that when, like, these to figure out what, like, this is like a constant math. Like, this is an equation that wouldn't change basically. Like, once we receive the initial metadata for each file from the info dict,
Mm.
the that data isn't going to change. So I don't really need to store it anywhere. We can just rerun that calculation and create a helper function for it to
Ye-
figure out where the piece is, if that makes sense.
but what if we need to? Hold on. Because actually saving that piece to disk would be hard because we're going to need to have multiple different file structs, uh, all accessing different parts of the disk. And, well, I guess that wouldn't be impossible. I mean, hmm. Okay, yeah, I see where you're going with that. I mean, I do.
Because we can always, like, figuring out where a piece starts and ends is not a problem.
Mm,
Figuring out what file owns which piece and what part of each piece the file owns is not very hard to do. We can easily make it like a singular
mm,
helper function to figure that out.
yeah.
And I don't think that would be that hard,
Okay.
in all honesty. I think we'll be fine.
Okay. Okay. Well, I'm gonna run with your confidence then. Okay, so let me, no, to correctly do this, to correctly do this, to
So the equation would be so yeah, I don't really do math. Well, I'm not that good at math, so I'm just
you're
gonna
you're
write this
you're
in like
you're, you're fine, man.
Python.
You're fine.
It's Python.
Oh
Um,
my God.
piece length equals uh, and then file length, and then this is just how my brain works. Sad. And
It is sad. It's okay. No, I'm joking. You're good, dude. You're good.
okay, so yeah, fi piece length, uh, piece out. So so the equation would be file length divided by piece count. Wait, would it? No, it would be, so dividing this by piece length would be
We'll give you the piece count.
well, no, it wouldn't. That would only be true for 12 if it was only one file. So
Oh,
yeah, the file length. Um,
wait. Okay, that does. Um, that does pose a different question then, because if that's, yeah, because that's not a standard length. Let me check the bent code thing again. I just look
yeah,
at.
check the bench out so I can like cook some actual numbers in here because it'll
Yeah,
help my brain.
no, it'll be fine. Okay, yeah, so okay,
Did you check?
that's the thing. So the file length is
Mm.
the total file length is not given, but the file length for each file is given. So what if we just do something like this? Okay, so if we have the, okay, if we have the, hold on, can I just like comment that? Oh, look, that I can. Beautiful. I'll cover that too. Okay, so we have the file length, for one equals, 100, file length 2 equals 1000, and piece length equals, let's say, 200. That resembles a similar situation to what we see in bigbuckbunny.torrent. And piece length equals 200. Then we know that the total pieces for one is going to be equal to file.
Well,
Good.
here's what I'm thinking. We would have like an offset counter.
Mm-hmm.
So like I have offset equals 0.
Mm-hmm.
And then we would go from here and have like 4 file and files. And then we'd go like and then we'd be like start byte equals offset and start piece piece equals start byte piece length, right?
Mm-hmm.
And then we would increment the offset by
The
the
file length.
file dot length.
See, that's the thing. That's not really necessary as far as I know. So, okay, so here,
Good.
yeah, because we can just use modulus to get, or modulo, I forget what, I think it's modulus, to get the remainder. So, okay, so what we can do, okay, so we have the total pieces for 1, that's going to round down to, so,
Mm,
0. So we do need 0 handling. Um,
mm,
here's, like, okay, so this method would require 0 handling, which would be fine.
mm.
Um, but then we can get the uh, bytes in that final piece by doing total piece, uh, piece bytes for 1 is equal to file length 1. Wait, let me make sure I'm doing this right. Also, that should be divided by. Wait, is that right? Yeah. No, that's right. Um, I gotta make sure my logic is right here. I think it should be file length 1 mod piece length. So in this case, this should equal 100. Let me check that real quick. Actually, I'm because I always forget this. So it should be like 100 mod 200 is one. Okay, so 200 mod 100.
Definitely, yeah.
Yeah. So 100 mod 200. So the smaller number basically. Wait. Is that right? Because, okay, so what I'm trying to do is get the remainder of that last piece that gives us the piece length. So if the, wait, yeah, should that file 1
And
length?
then we can compare the we can compare the remainder of this function to see and if it's less than piece length, then we know that if it's less than piece length, that means that we know that it feeds into the next piece, I think.
Yeah. Okay, I think you're right. Yeah.
Or that means it's like incomplete, if that makes sense.
Yeah. No, it does. Wait, so how do we do that again? So, because I'm looking to do, okay, because like, okay, because like 1,000 here. Okay,
Because I want to have like a function that like a function called like def uh and this would be like on have like def is in piece piece index, and it'd be and we would run this calculation, so it would return a boolean,
mm-hmm.
and that could probably be like our helper function to figure out what pieces each file, or we could have like a piece map almost.
Yeah. Okay.
Well, we don't really need a piece map because like this is a constant thing that we can. Yeah, well, we could have a piece map. We can have a piece map in like self that we have
Yeah. Yeah. Okay, wait,
like
so
maps each file in their pieces and whatever.
yeah.
So we can, this is part of seeding back to other people. That's like the main thing here
Yeah.
when we want to send these pieces back.
Yeah. Okay,
Um,
that seems fine. Okay, so then yeah, so okay. Yeah, so okay, so I checked. So this should work. And then okay, so you're saying that would go. Wait, I think would that go?
I'll go
Isn't
in a torrent file struct.
Yeah, I was gonna say. Okay, so okay, we can get the number of piece bytes. This is so hard to model and like think about.
Yeah.
What is YouTube mad at me about? Is not receiving enough video to maintain smooth streaming. You're gonna be fine, YouTube. you're gonna be fine. I think my internet is just crashing out a little bit. That happens.
Internet seems fine to me.
I don't know, man. It's just I don't know. It doesn't matter.
Hmm.
Yeah. Okay, cause
Well, 4 viewers, by the way.
I know,
Isn't it?
I know, my a grand total, grand total.
Rent.
I
Rent.
know.
Rent.
Yeah. Okay, so maybe we just hold on, cause I need to see. Oh wait, hold on, hold on. What about this? Okay, so what if we did this? Hold on. I'm about to cook. So remainder bytes it's equal to 0. So then, okay, so let's do for file and files. Okay, so let's see. So num pieces is equal to file dot length divided by piece length. So let's yank this down. Divide by piece length. Then okay, so let's see remainder byte. Here we go. Oh yeah. Okay. So then. Okay, so remainder bytes is equal to. This is so weird, dude. Oh my gosh.
Bro.
What?
I'm low key trying to look at like another implementation of this, like in libRcuba or something, or create torrent.
That's do you go for
So
that,
let's see.
dude? 100%. I'm so wildly clueless here. Well, I'm not clueless. It's
Yeah.
just it's so many numbers to take in.
Supposed to be the math guy, man.
Hey, calculus, man, calculus. That's all I did well on, man. I got 5 on the AP, and then I'm out. I'm out. I can't tell you how to get the number of pieces in a file, but I can tell you how to integrate the second derivative of any given function f.
No habla español.
Nah, you'll be fine. You're fine. Calc's fun. Calc's fun. You're gonna love it.
Nerd.
No. I'm serious. It's fun. Don't call me a nerd.
Uh-huh.
Don't call me a nerd.
Hmm.
Calc's fun. Deal with it. Remainder bytes is equal to. Hold on. Where could I? I'm looking for a thing now. This dude then. Ba-ba-da-ba-da.
Also, I'm adding a set output stream. So basically, we're basically allowing it basically allows the person consuming the library to have like something custom that will take in the bytes that we're receiving
Okay. Yeah.
and stream it into something. So that could be a custom. They could stream it themselves to a file through Tokyo, or they could just stream it to yeah. So this is would basically let the user just do whatever they want with the bytes they're receiving, like raw.
Okay. Yeah. That seems.
So that could be streaming it to, like, if it's a video, it could be streaming it to the browser directly. It could do whatever they want with this. So
Okay.
that's what that is for.
Okay. Yeah, that's fine.
So this would.
Okay. Remainder bytes. Okay, so remainder bytes should be file length piece length.
Not right. But actually, we have to write.
Pieces, num pieces. Get all pieces pieces, and then pieces at negative. From I forgot how to do Python slicing. I haven't done that in so long.
Rust slicing is better.
I'm sure, buddy. I'm sure. From
Everything
0.
else is better.
I know.
Yeah, like my window manager and my IDE and my
Yes. Yes.
shell
Oh my
and
god.
what
Oh
else
my
is written in
god.
Rust?
Oh,
I
oh
have
my god.
everything I use is written in Rust, by the way.
I can tell. Yeah.
I can't bear to use transmission anymore. It's written in C++. I use a
Mhm.
Rust spacing. That's why I'm building this thing. I can't bear it.
Oh my god. Huh. Okay, so pieces is equal to get pieces, and then get all pieces and attach the bytes to get all pieces except the odd one out. The last piece. The last piece where bytes where the piece ends before where the piece ends before blah blah blah, where the piece ends before where the file ends before the piece ends, or file ends before the piece ends. Okay. A final piece is equal to get piece. Wait, let me think. Oh, this is weird. Okay, so let's see. So, oh my god, dude. Okay, I might have to come back to this tomorrow. I'm not gonna lie. My brain is completely fogged.
Really?
Yeah.
Got on stream already?
Dude, hey, look. You were the one playing Minecraft. You were locked in on Minecraft. I want to be that guy.
What? Don't blame this on me. Don't blame this on me.
I want to be that guy. No, but actually, I am gonna get off because I'm so tired.
All right.
All right.
I'm gonna try to figure this out.
Yeah.
Sorry for the short stream, chat.
It was like an hour and 30 minutes. I got like
We didn't do any actual coding.
I
Oh,
know.
and someone just had hello team. We're at peak viewers. What are you doing, Oscar?
I'm
coding,
throwing. I'm throwing. Yeah. Well, yeah. We're not doing much coding. Yeah. My brain is so okay.
We're at peak viewers.
Why,
We're at peak viewers.
Why?
What are you doing?
I'm throwing.
Bro, no revenue.
No. Okay,
I'm
yeah.
trying to convince them to stay longer.
No, I'm gonna I don't know if I can stream tomorrow night. Because I'm hanging out with my girlfriend, but I could probably do Sunday night if I don't go out with my buddy. What? I know. Look, dude. Look.
Oh, wait, tomorrow's Saturday, right?
Yeah, Saturday.
Oh, I don't know if I'll be able to stream because I have a tournament match tomorrow.
You have your
I don't know if I'll
OSU
be-
competition. We know.
Yeah,
No.
I don't know if I'll
Nah, I'm joking.
be
Good
there
luck.
to yeah. I don't know if I might not be there on stream, but I'll obviously be coding off stream. But also you need to get your daily commit in, and I don't think
I
this
did.
counts as a commit.
I did. I opened that issue. Don't worry.
Oh.
Don't worry. I'm
You
prepared
little-
for these things.
Oh my god, this guy.
uh,
What a weasel.
I
Oh my
know.
goodness, he gets his daily commit and then sneaks off.
Yeah, you're welcome. Okay. Yeah. Yeah.
What?
What?
Welcome is crazy. Nothing.
Huh?
Nothing.
What? Okay.
Welcome is crazy.
Where did I say welcome? What?
Yeah, bro, go to sleep. It's okay. So yeah, just go to sleep.
Okay. I'm being gaslit now. Okay. Yeah, I'm gonna
Rewind the stream like 2 seconds.
I
You
don't
just said
know.
you're welcome.
Did I?
Yes.
I'm being so
What?
genuine. I do not remember that. Okay, I actually need to go to
rewind the
bed.
stream right now. No, rewind the stream right now. No.
Oh, no. Okay, I will after. No. I believe you. I believe you. I'm being so genuine. I'm just tired. Okay. Yeah, I'm gonna.
We're at 6 views. Oh my god.
I'm throwing. Okay, yeah. Sorry, chat. Sorry, chat. Okay, okay. We'll be back later. We'll be
Yeah.
back later. We'll be back later with a Red Bull and some other form of caffeine. Probably tomorrow or Sunday. Yeah.
Just keep going up.
Actually, bro, why? Why? Dude, worst timing. Worst timing ever. So bad. Oh my god. Okay, yeah, I'm gonna. Okay, I'm gonna go to bed too. Good night. Good night, chat. Sorry, chat.